Hi guys, in this video we're going to be looking at a very simple experiment to do with whether sound appears to be clearer when heard through a solid, a liquid or a gas. So in order to do this we'll need three things. We'll need a gas, which is very convenient because it's all around us. We'll need a solid. In a classroom, just use your table. And you'll need a liquid. In this case I've just filled a tray with water. And the inconvenient part of this as a teacher is that your class are going to get a little bit wet with this. So in order to do this, I would start off with getting your children to come up with their hypothesis. Do they think that the sound will appear louder when heard through a solid, liquid or gas? And why? You can maybe encourage their thinking along the lines of density if they have some knowledge of that. Maybe if you've already covered solids, liquids and gases in the past, then they might have some idea of the density of each of these different states of matter, and that might help to formulate their thinking. If not, no worries, they can just come up with a hypothesis and then they will either confirm or reject that hypothesis after doing the experiment. So, all you're going to be doing is creating a sound. I'm going to do it by dropping a ball and listening to it through a solid, and liquid and a gas. In essence, that sounds simple. However, the challenge comes in getting your kids to think about how to make this a fair test. So in order to do that, and you could get the class to brainstorm this, in order to do this, there's different variables. So we could vary the type of sound that's produced. We don't want to do that because the one thing we're varying is the different mediums we're hearing it through. So we need to find a way of keeping the sound as consistent as possible. We also need to be listening to it across the same distance every time. Obviously, if I'm listening to a sound up close, it's going to appear much louder than if I'm listening to it from further away. So the distance between my ear and the sound needs to be the same in each of the three conditions. So there's two things for the class to think about. One, creating a consistent sound, and two, having a consistent distance between them. So lots of different ways of doing this. I would encourage them to think about using a regularly shaped object. I've gone for a hockey ball in this case. And to create a fairly consistent sound, you can just drop it from the same height every time. So I'm going to hold it at 20 centimeters. I get that sound there. I can drop it again from 20 centimeters, and I get pretty much the same sound. Drop it in a different place from 20 centimeters, still a fairly consistent sound. Okay, so that's one way of creating a consistent sound. Next, I need to be measuring it from the same distance every time. So that's where things get a little bit more challenging. The way I would get the kids to do this is to actually use a ruler, measure the distance between their ear and where the ball is being dropped. So to start off with, I'm going to put the ruler flat. I'm going to put my ear at 30 centimeters, the ball at 20 centimeters, drop it, and I'm measuring, albeit very subjectively, it's based on my own opinion really, but I'm measuring, using my ear, how loud the sound is. Next, I'm going to do the same thing. I'm going to measure, I'm going to have my ear against the table this time. So I'll have my ear there, the ball here. I'd have to measure it up 20 centimeters. This is why you need a partner. I'm not going to go doing this myself, but you can imagine the ball would be 20 centimeters high and 30 centimeters away from my ear. And when I drop it, I'm going to be comparing the sound. And what I'm doing there is I'm hearing the sound through a solid medium, through the table, which is solid in this case. Lastly, I'm going to do the same thing, but I'm going to be listening to the sound through a liquid. Now, this one isn't a completely fair test, but I think in a classroom setting it's the best we can do. So I'm going to put my ear, or I'm not, but I would put my ear in the water, measure a 30 centimeter distance, okay, so about there for my ear is where I would drop it, and again drop it from the same height again. Now, that means that the sound is propagating through the table, which is solid, through the tray, which is solid, but the last portion, the last distance that it's travelling is through a liquid medium. So I am hearing it through a liquid. It's not going through a liquid the whole way. Again, there's limitations with what we can do in a classroom. But that way we're comparing through a solid, through a liquid, and through a gas just by hearing it through the air. And they can either confirm or reject their hypothesis, and they've had practice in using a fair methodology and actually thought about the process behind that. Cheers!